This estimate is based on studies of the local universe. But we are quite sure that this portion we can see is only a small part of what could be an infinite universe that we do not yet know. We are not separate from the universe but are an integral part of it. We are, in a way, the means through which the universe knows itself. With the help of the James Webb Telescope, we embark on a vast exploration to discover the true size of our universe. For perspective, if we were traveling at a speed of 70 miles per hour, it would take us about 15 days to complete one lap around Earth's equator. It would take approximately 5 months to reach the Moon, 63 years to reach Mars at its closest point, and a staggering 4,400 years to reach Neptune. These figures alone demonstrate the immense scale of our solar system. To put this into context, consider the Voyager 1 probe launched in 1977. It traveled at a speed of 38,000 miles per hour and did not leave the solar system until 2012, meaning it spent 35 years just to exit our solar system. Even light, which can circle the Earth 7 times in a single second, seems relatively slow compared to the vastness of our solar system. And although our solar system is vast, it is dwarfed by the enormity of the Milky Way galaxy. The Milky Way contains approximately 300 billion stars, each of which likely has its own planetary systems. Our nearest neighboring star, Alpha Centauri, is 4.3 light-years away, which means that if we were to travel at the speed of light, it would still take us 4.3 years to get there. Now, imagine the time it would take to reach Alpha Centauri at the speed of the Voyager probe, 38,000 miles per hour. It would take a staggering 70,000 years. This highlights the immensity of the distances involved in exploring the cosmos. Let us now focus on Velt Rouge, a star located 640 light-years away. Considering what we call the radiosphere, which represents the distance our radio transmissions have covered in the last century, the signals, though significantly degraded, have so far reached about 15,000 star systems. However, this figure is only a fraction compared to the number of stars in the Milky Way. If you look at Velt Rouge in the night sky tonight, you're actually seeing light that left its surface 640 years ago, about 100 years before Columbus set sail for the New World. This light has struggled across the universe for all that time and is just now reaching our planet. It is truly amazing to realize that Velt Rouge, on a universal scale, is relatively close. To amaze you even more, consider that our radiosphere, which encompasses all human radio transmissions, is minuscule within the immense expanse of the Milky Way. To help us imagine this, if we were to reduce our solar system to the size of a quarter placed on a map of the United States, then the entire Milky Way would be as vast as the entire planet Earth. In this immense region, there are about 300 billion star systems and their planets. We are just one of those 300 billion systems floating in the midst of an unimaginably large number of stars and planets beyond our galaxy. There are at least 1 trillion more galaxies. Yes, 1 trillion. 1 trillion is an incredibly large number. To understand its magnitude, imagine a collection of 1,000 cats. Now, suppose that there are 1,000 groups of cats, each consisting of 1,000 cats. That gives us 1,000,000 cats. But to understand 1 trillion, remember that 1 trillion equals 1,000,000 times 1,000,000, a staggering number of cat encounters. Our nearest neighboring galaxy is the Andromeda Galaxy, located 2.5 million light-years away. Andromeda is rapidly approaching us at a tremendous speed. As this galaxy approaches, our night sky will undergo significant changes. The Andromeda Galaxy contains about 1 trillion stars. When it eventually collides with our own Milky Way galaxy, which has 300 billion stars, the chances of individual stars from both galaxies colliding are quite slim. This illustrates the vastness of space and the low probability of direct interactions between stars within a galaxy. Galactic collisions, although rare at the level of individual stars, may even facilitate life between stars and galaxies. Galaxies are not static systems. They are dynamic and constantly evolving. As we move away from our galaxy, we encounter our local group of galaxies, followed by the Virgo cluster, which contains more than 1,500 galaxies. The Virgo cluster is part of a larger supercluster known as Laniakea, which contains approximately 100,000 galaxies. Each of these 100,000 galaxies has hundreds of billions of stars and planets of its own. And this is only a small part of the big picture. In the observable universe, there are another 10 million similar superclusters. As we zoom out and observe, we discover an increasing number of mapped galaxies. These are the galaxies we've identified and charted. However, these mapped galaxies represent only a small fraction of what is actually out there. There are hundreds of billions of galaxies that have not yet been fully mapped. In addition, we must consider the cosmic background radiation, which represents the oldest detectable light, the residual heat left over from the Big Bang. This radiation is a remnant from the early stages of our universe's existence. The scale of the universe becomes even more staggering when we consider the vastness beyond galaxies. We find regions in space known as cosmic voids where matter is scarce compared to the rest of the universe. These cosmic voids are immense, spanning hundreds of millions of light-years in diameter and appear as vast expanses of seemingly empty space. However, these voids have the potential to give rise to the formation of future structures and galaxies. As we move deeper into the cosmos, we encounter cosmic filaments, which are colossal threads composed of dust, gas, and dark matter that stretch across billions of light-years, connecting galaxies and galaxy clusters. These cosmic filaments form a cosmic web-like structure that binds the universe together through gravitational interaction. The distribution of matter in the universe is not uniform but shows a cosmic web pattern where clusters and superclusters of galaxies are connected by these cosmic filaments. This creates an intricate tapestry that spans unimaginable distances. It is within these cosmic filaments and superclusters that galaxies congregate, interacting through gravity. The vastness of space offers a grand and abundant stage to the existence of countless celestial objects and phenomena. For example, supernovae, the explosive deaths of massive stars, disperse heavy elements throughout the cosmos and enrich the interstellar medium and planetary systems. Black holes, with their immense gravity, play a determining role in the evolution of galaxies and can release jets of energy that extend great distances into space. In the depths of space, we also find exotic phenomena such as quasars, which are supermassive black holes that feed on intermittent matter and emit colossal amounts of energy. These quasars can eclipse entire galaxies and act as beacons of the early universe, allowing us to study the cosmos in its early stages. The question arises, however, what lies beyond the observable universe? There are numerous additional galaxies beyond our visual reach, as the light from these galaxies has not had enough time to reach Earth. In addition, due to the continuous expansion of space and the constant motion of galaxies, the light from most of these distant galaxies will never reach us. As a result, these regions may remain inaccessible to us indefinitely. As the universe extends, we can make inferences based on our understanding of the laws of physics. These inferences suggest that the entire universe is at least 250 times larger than the observable universe. In fact, there are compelling arguments suggesting that its size could be even larger, potentially infinite. In this context, a broader perspective emerges that leads us to consider the nature of the universe and our place in it as human beings on a remote planet within the vast expanse of space. Contemplating these possibilities invites us to reflect on our existence and our roles in the cosmos. So, have you ever wondered how vast our universe is? Well, if so, I hope this video has helped you to understand even a little more the immensity of the cosmos. I hope you use the comment box to share any questions. And if you like the video, hit the like button, share it to reach more people, and subscribe to not miss more content like this. Thank you so much for watching the video, and see you in the next. As we continue our journey through the cosmos, it's important to realize that our understanding of the universe is constantly evolving. New instruments such as the James Webb Space Telescope have opened up possibilities that were once the domain of science fiction. These tools not only allow us to peer into the early universe but also to analyze the atmospheres of exoplanets, bringing us closer to answering one of the most profound questions: are we alone in the universe? In recent years, astronomers have identified thousands of exoplanets orbiting distant stars. Many of these planets exist within the habitable zone, the region around a star where conditions might be right for liquid water and potentially life to exist. Some of these planets are Earth-like in size and composition, while others are gas giants or icy worlds with subsurface oceans. The sheer number of these planets, estimated to be in the billions within our own galaxy, suggests that the conditions for life may not be as rare as once thought. But even beyond the search for life, the universe itself holds countless mysteries. Consider dark matter and dark energy, two components that make up about 95% of the total mass energy content of the universe. Dark matter, which exerts gravitational effects but emits no light, helps explain the movement of galaxies and the structure of the cosmic web. Dark energy, on the other hand, is a force thought to be responsible for the accelerating expansion of the universe. Despite their profound effects, both remain largely theoretical and undetected directly. And then there's the concept of the multiverse. Some physicists propose that our universe might be just one of an infinite number of universes, each with its own physical laws, dimensions, and potential for life. These other universes could be entirely disconnected from our own. While they might exist in higher dimensional space, only accessible through mathematical theory or quantum fluctuations. This idea, while speculative, offers a staggering perspective on the possibilities beyond our cosmic horizon. Time, too, is relative in the universe. As Einstein's theory of relativity demonstrates, time slows down near massive objects, a phenomenon known as gravitational time dilation. This means that time on a space station orbiting close to a black hole would pass more slowly than on Earth. It's a mind-bending concept that has been confirmed by experiments and even has implications for space travel and our understanding of the fabric of space-time. Speaking of black holes, these aren't just cosmic vacuum cleaners. They're engines of extreme physics. At the center of almost every large galaxy lies a supermassive black